Good morning, everyone. I'm Shasino Ken, scientist here from Central Groundwater Board, and currently I'm posted at State Unit Office, Shillong. So in this first lecture, I will be taking up on this topic, that is a basic concept of sprints. Like it includes what is sprints, what are the different types of sprint or the genesis, and with special emphasis on sprints of Northeast India. So I will just show, like, we have been working on sprints for the past few years. So I will just show some of my experiences, like what are the different types of sprints found in northeastern states. So to start with, I think yesterday Gogoi sir has already taken up basic of hydrogeology of Northeast India. So like why this sprint is very important, especially for northeastern states, because we can see that northeastern states are mainly covered by, the terrain is hilly terrain, and local people are very much dependent on these springs for their drinking, for other domestic purpose also, and even for irrigation purpose also. So that is why, and this spring is one of the major source of water, especially for northeastern states. And as we all know, spring is also a groundwater. So why hydrogeology is, what is hydrogeology and why it is important in the study of springs? So we all know that yesterday he has already explained, so I will just recap what is meant by hydrogeology. So hydrogeology, as we all know, it is a study, in a very simple term, study of groundwater, and which means like how the water are infiltrated, that is the recharge, and how it is interacting or stored in this subsurface aquifer, that is the aquifer, and how it interacts with the rocks or the soils, which forms the geology. So it comprises of the chemical, physical, and environmental characteristics, and therefore we can say that it deals with the distribution, the interaction, as you can see in this sketch, and the movement of groundwater on the Earth's subsurface in relation to the geological environment. And we can see, as you can see in this sketch, like this is how, like when it rains, it gets infiltrated and it recharges the aquifer system. And some we can extract the groundwater in the form of duct well or the bore well, or some it comes naturally in a point focus, like as you can see. So it is like, it is a spring where it is coming out naturally, the groundwater comes out naturally on the surface. So why this hydrogeology is very important in spring studies? Through this hydrogeology, we can understand the regional and local geology, as well as the structures existing in that particular area, and also the topography, the aquifer system, and the characteristics. Therefore, it is very important in spring studies. So we'll first start with what is a spring. So in 1995, Todd is a very popular scientist and author. He defines spring as a concentrated discharge of groundwater appearing at the ground surface as flowing water. As you can see in this photograph, these are some of the field photographs in like Meghalaya, Nagaland, and yeah. So in other words, we can also define as spring as a focused discharge of naturally occurring. It should be naturally occurring, like in some places people used to dug and then the water used to come out. Those are artificial, so we can't count them as a spring, but it should be a naturally occurring groundwater on the Earth's surface. As you can see in this, these are we can say that these are artificial structures, but this is just a storage chamber, na? So though the water comes out naturally from this one, so this is also a spring, and this is fracture spring. So I will come in that type of different springs. So yeah. So why spring? Why do we need to study spring? Or why is, like the government is also emphasizing on springs? Why it is gaining more importance in spring? Because we all know that spring is a lifeline for the hilly region, especially for the hilly region of Indian Himalayan region and the eastern and western, and in some parts of eastern and western Ghats. And we can see that it is the only source of water for all uses in the hilly region. Like especially even me, I come from Nagaland state, which is also a hilly state, and I know the importance of these springs in a hilly region. And we can also see that especially in northeastern state, we don't have much snow-fed river. Na? So those rivers are, the springs in those hilly regions are the main feeder of the mountain hilly rivers. We can say that it is the main feeder of mountain or hilly rivers, especially in those northeastern states. And like you can see in this photograph, why it is very important. Like, it's people used to line up early in the morning to fetch water from these springs, and then so these are the photographs taken by Madam. Previous year we did some studies in Kohima districts. So this is how like people are lined up. They used to put their bucket and all to fetch water from this. So it is very important, especially people living in hilly region. And springs, like they also, through these springs, they used to supply water through this water tanker truck and all. It's in Tamil districts in Nagaland. And this is how they used to make this bamboo irrigation channel, and then make some, and then they used to irrigate some terrace paddy cultivation also in Nagaland. That is in Nagaland. So the next is why there is a need for spring studies. Like over these recent years, we have seen that especially in northeastern. So all these photographs is from northeastern states only. So we have seen that there is drying up or decline in spring discharge. Even in northeastern states, there are various factors contributing to this drying up or decline in spring discharge. And the source, like the main water source, are also getting decline or it's getting dried up. So there is an issue on source sustainability also. And because of this impact of climate change, and springs are very sensitive when it comes to climate, because the discharge depends on the climate also. So this is how it is happening presently. And it is not of that alarm stage, but we can say that if we don't take steps now, in future, we don't know what it will happen. So it's very important that we need to go into detail of spring studies before it is too late. So you can, as you can see in these photographs, this is in Shillong area. So during earlier, they said that earlier, maybe 10, 20 years back, this spring was perennial. But during 2023-24, we did some studies, and we found that it's completely dried up during lean period. Even this spring, same case. And this one is in Nagaland. Last year, we worked in Nagaland. So actually, there is one video also, and I discussed with this one lady. She was fetching water. Actually, during monsoon season, this entire area is fully filled up. So it's a fracture spring, like the water used to seep out from that fracture. And during this lean period, she said that it takes her like 2-3 hours to fetch this much bucket. That is how like people are so much dependent on these springs. And this one is in Shillong area. It's a huge discharge spring, and people used to fetch water for drinking purpose as well as mostly for washing clothes also. So one day, the springs suddenly got dried up, and just within 2-3 hours when they were washing clothes and all. So Scott sir, he was an ex-member of CWC. He called me up and he said that there is some issue in this. This is in Maulai area. So he called me up and we have to go and, the Dorbash now, they are requesting us to come and do some survey. So when we went there, it was completely dried up. Because this entire locality is, they are dependent on these springs for their washing, especially for washing and for drinking purpose also. So when we visited in this site, we found that it's completely dried up. But they say that after sometimes the water used to come out. So when we inquire about it, and the local people, that is why hydrogeology is very important when it comes to spring study. So when we inquire about it, we found out that there is a PHE borewell, water supply borewell, as well as in that spring shade area, there is some private borewell also. And then nearby that area, there is one private borewell, just near, I think around 10-20 meters. There is private borewell where you used to pump them a whole day and supply it to this true water tanker. So that is the main reason behind this one. So as I think yesterday, he has already explained how the aquifer exists on the subsurface. So actually the springs, the water that is coming out, it's from that same aquifer that is tapping from those bore wells. So we give some suggestion that the Dorbar should not should some regulate those bore wells and all. No? Otherwise, these springs will get dried up. So that is how, I mean, without properly understanding the subsurface geology or the aquifer system, people used to, I mean, rapidly they used to drill bore well and all. So it affects the springs. So the next is like, so we now we know what is springs. So, and coming to the classification of springs. So there are different type classification of springs, but I will just concentrate on the main classification. So, so springs based on the spring flow, springs can be classified as gravitational or non-gravitational. So Brian in 1999 divided these springs into two types, that is springs resulting from non-gravitational force and gravitational force. So non-gravitational force, like through this we call as piezometric pressure, or through fracture springs, volcanic springs, mainly from those, it comes under like the pressure that not naturally flowing, but through those pressures. And then gravitational force like depression, contact, which I'll come into in the next slides later. So these are true gravitational force. And based on the hydrogeological condition, types of lithology, average discharge. So all these classification, they have various classification of springs based on the type of lithology or average discharge measure classification. But I will be concentrated on the most common that even CGWB also use, or other NIH also use, is hydrogeological conditions. So I will just go into that one. So based on the hydrogeological condition, the springs can be classified into this fracture or fault springs, depression springs, contact springs, karst spring, and thermal springs. Why I have marked fracture or fault and depression spring in red mark? Because these two type of springs are the most common type of springs found in even in northeastern India. So yeah, I have just marked that one. Though other type of springs are also found in northeastern India. So coming to the first type of spring is fracture or fault spring. So when in this type of springs, when groundwater emanates through fractures or fissures or faults, and the water comes out naturally, it is called fracture springs. Like say these are on the subsurface, especially in hard rock, like hard rock terrain. There will be lots of fractures on, and through that, let's say even if like if there is one bore well, if they tape this kind of fractures on, the water come out, like especially in hard rock. So likewise, if this fracture zone touches the surface and the water comes out naturally, that we call as fracture springs, or maybe fault spring also, like when the fault touches the subsurface, I mean the surface, and if the water comes out naturally, we call as fracture springs. So these are some of the field photographs, especially, I mean, these are mainly from Meghalaya. So you in field, actually, in say, when we see the sketch, we can easily understand, right? Like, okay, this is fracture spring. But actually in field, it's very difficult to identify also. I mean, some of you might have some field experiences. So in field, we can see like if there is hard rock, and then if there is some clear fracture zone and the water coming out naturally, we can say that this is fracture spring. So when it comes to spring shed management, it's very important to know the different type of springs, because based on the type of springs, the spring shed demarcation or the recharge structures that you are planning to come up, it depends on the type of spring also, and where the recharge zone is located. It depends on the type of spring. So the next lecture, I think she will also highlight something on that one. So this is like a short video that fracture spring, which is in Meghalaya. Okay, the video can't play. Actually, it's video है. अच्छा, it's in this folder only. Yeah. Fracture spring, yeah, this one. Okay. Just to show like in actual field condition how the fractures spring exists. So we can see clearly that there is a fracture in this area. I mean in this zone. So this is how the fracture springs exist in, and the other one, yeah, there is one huge fracture. So this one is a big like high discharge fracture springs. Just to show you some idea like how it exists in actual field condition. So coming to the next type of springs, that is depression springs. So this is also a very common type of springs found in northeastern India, and we can define this type of spring as like where it is formed when water table reaches the surface due to topographic condition. As you can see, this sketch clearly that like if there is some undulatory topography or and then water table touches the surface and then the water comes out or seeps out naturally, we call as depression spring, which is very common. And I think most of the when you go to field or when you observe it, you will find most of the springs in this type of springs, that is depression springs. These are some of the field photographs. Aminda is in Garu Hills, and this one is in Nagaland, and then Smith in Meghalaya. Yeah. So this type of spring exists when there is undulatory, like if there is a sharp cut and then the water tables, through that water tables touches the surface, and the water is to seep out naturally. So this is another video. So actually why we call the springs as mountain or a mountain river feeder, na? I'll just show you this video once. So this spring is, see, you can see that there is a depression spring and the water is flowing out naturally. Na? Places you can find like 4-5 LPS or adjacent to this, I think around 500 or 1 kilometer from this one also. There is a huge depression springs like around 5 LPS. So, and it feeds the river in those areas. Na? And in this, like those springs which are existing in thick forest area, like people are not fetching water from those areas. So those are the main feeder of rivers in those hilly area. So coming to the next type of spring, that is contact spring. So in this type of spring, when a permeable strata overlying on an impermeable formation, as you can see in this sketch, the, hard rock, this is an impermeable strata where the water cannot percolate down, right? And then if there is, this is like aquifer zone or the sandy or boulder or gravel zone where the water is stored. And if this zone, if it touches the surface and the water comes out naturally, we call those as contact springs. And likewise, in those other sketches, it represents the contact springs. And this is like actual field condition. We can see that this is like hard quartzite formation. Above that is a weathered, like weathered formation, and the water in between this contact zone of this weathered and hard rock quartzite formation, the water is coming out. So it's a contact springs. And you can see in this, you can see some splintery shell type, right, in this formation, and then this is like massive limestone. So in between that one, there is water coming out, which we call as contact spring. And this one is actually this one is not a natural one, but just to show you like how contact springs exist in actual field condition. This is in Arunachal Pradesh. It's in Kimim formation, bouldery or gravel bed, and then clay. Clay, we know that the water cannot, it's an impermeable strata. So in between that one, there is water coming up because the water is, stored here, and then when it touches that clay bed, it can infiltrate, right? So the water, it comes out in that contact zone. So this, the next one is carved spring, which is not very common in northeastern state, but it's found in some places. So this type of springs, like it gives the huge discharge. So these type of springs are formed when a carbonate rock like limestone dolomites due to dissolution, we know that it's a dissolution rock, a type of rock material. So when there is a dissolution of rock materials by chemical reaction, they used to form cavities, or we call as caverns. And in those caverns, when the water stored in those caverns and then it comes out, we call those as karst springs, as you can see in this sketch. And this is like in Meghalaya. Meghalaya, we know that there is a limestone formation, especially in those Cherrapunji area, Mamluk caves, those. So this is a Mamluk caves where there the water is, huge discharge is coming out, especially during right after monsoon season. And the last one, that is the thermal spring. Thermal spring is like when the water, the spring water temperature, is more than the normal temperature. We call those as thermal spring, and it is mainly due to like when the water infiltrate and seeps down deep down, like say 3,000 meters or 5,000 meters, or let's say 3, 4, 5 kilometers, and if it touches like the high temperature and then comes out with high temperature water, then we call as thermal springs. In this is having a temperature more than the normal local water. We call those as thermal springs, and it's found in northeastern state also, garam pani, or like we used to call that one. So I'll just show Meghalaya. So Meghalaya has two thermal spring or hot spring we call. One is at Jagram hot spring, and another one at Rasalbepara hot spring. So Rasalbepara, we know that it's in North Garo Hills district, and Jagram it's in East Khasi Hills district. I think some of you have been to Jagram hot spring. So like when we compare with the temperature, Jagram hot spring is much more higher than the Rasalbepara. Rasalbepara, I think when it is in winter season, we can feel the difference. Otherwise, it's not that hot also, but it's a thermal spring. So that concludes the this one, hydrogeological classification of springs. The next one is Menzer's classification. So Menzer has classified springs based on the mean discharge, the ranges of mean discharge of springs. So he classified springs into 8 magnitude. So based on the mean discharge, say if the mean discharge ranges more than 10 meter cube per second, he classified as first magnitude. Likewise, second, third, fourth, like say, so the most common which we can find is, in northeastern states are from 5th, 6th, and 7th. So 5th, like say 1 to 10 liter per second, or 6, 0.1 to 1 liter per second. Like that. So mostly in northeastern states we can find on the this 5th, 6th, 7th, 8th magnitude. So apart from those normal, those springs, there is also springs called saline or brine spring. So these type of springs are found in Assam, or I heard that in some Arunachal also, in Nagaland, in Manipur also. So like say in this case, it's found in Matikru village, which is in Meluri district. Now it's Meluri has become a district. So Meluri, earlier it was in Pek district, Pek. So the local people, they used to fetch water from this brine spring, and then they used to boil it and make salt cake, and they used to sell it. Yeah. So I'll just so that concludes the basic part of springs. Now I'll just 2, 3 slides are there, just springs of northeastern India, like our CGWB, what we have done so far. So like this is like a compilation from 2015 to 2024. So in between that one, we have done some inventory of around 455 springs. So after 2024 also we are continuing. 455 springs we done, inventory was done, and then during that inventory we have collected like what are different type of springs, discharge quality, and then discharge measurement through bucket or like V-notch, and then we did some local community survey also, and then water quality analysis was also done in those springs. So some of the key findings, we found out that most of the springs are perennial. Like say in that 455 springs, around 97.6% were perennial, and then 2.4% non-perennial, which gets dried up during lean period. And then the type of springs that we found in those 455 springs, like around 50% is like depression type of spring, which is the most common type of springs found in Northeast India, and then fracture springs around 45%. So we can see that most of the springs are from this category only, and then contact springs around 3%. So apart from this, there are combination of say fracture come contact springs or fractures come depression springs. Those type of springs are also exist in actual field condition also. So yeah. So when we plot it in that Menzer classification Menzer classification, we found out that most of the springs discharge ranges from this category, that is 10 to 100 milliliter per second, and then 38.9% falls in 0.1 to 1 liter per second, and very few springs in this 10 to 100 liter, just some 4 or 5 springs or 2 3 springs exist in, giving discharge of more than 10 liters per second. So when we also did some spring water quality, especially for irrigation purpose, we did some analysis, and we found that most of the parameters falls within the permissible limit, and which is good for irrigation purpose also. And this is like one spring which is in Meghalaya, Mokrewa. This is how they used to make some irrigation channel. From actually the front part is like poor rice paddy cultivation. So this is how they used to do some irrigation channel and then irrigate those area. And so this is the last slides on this topic. So we also did some cluster of spring study at Mount Turgut. So this is like in Nagaland. So especially in hilly area, people are very much dependent on these springs. Their only source of water is from springs. So just to cite one example, so this is a mountain that is called Mount Terugunyu, and then in this mountain, this is a mount and very famous in that area. So in this area, there is around 16 springs. So this adjoining to this mount, there is 5-6 villages. Even some towns are also dependent on this. So these are the main water source of those villages and towns in that area. And so we have come up with the spring shed demarcation, and then this one identify the recharge area of that these springs in this area based on the different layer. Like we did some slope analysis, landslide, and then the topography, and also depending on the slope, we have come up with like how much area the recharge area is, and then the size of the trench and volume. So this is how springs are being studied, and then how we can come up with some spring shed management plans in that area. So yeah, that concludes my first presentation. If you have any queries or any doubts, you can you are free to ask, please. Yeah, it took only 30 minutes, but yeah, we can have more discussion if you want.
Sir,
yeah. Origin point. So you have to go to the field, and then where the water is coming out, that point. You mean that point, the focus point? Yes, yeah. So you have to go to the field. Like people used to, some people they used to say that the waterfall can also be springs, but we have to go to the field and locate the exact point where the water is coming out. Yeah. See, I'll just show you those. I have already shown, but okay. See, even that case also okay. See, this is the point where the water is coming out, right?
It is the outlet. So origin is coming from somewhere else.
Oh, you mean the subsurface? Oh, recharge point. You mean the recharge of this particular spring? Yeah. So, yeah, those actually. So Morphy, next lecture she will give some brief idea on that one. But to identify the exact recharge area, it's it takes lots of effort, and then you have to do some field study, and then she will cover that part also. But so depending on getting to know the basic is very important. Say if it is depression spring, there is some thumb rule for depression spring, or for fracture spring, there is some thumb rule like where the recharge area will be located. So she will cover that part. Yeah.
Sir, is it most of the springs are in hilly areas?
Yeah.
In plain area also?
Plain area, I don't think it's possible because
Plain area also we can see some spring.
say the water table, say depression type of springs. If there's in plain area, also if there's some slight undulatory terrain, and then the water table when it touches the surface, it can. I mean, you can find some springs. But plain area, very rare you will find springs, because the spring definition itself is like a naturally groundwater appearing on the ground surface in a focus point. Nah? So like if it is plain area, there is less chance that it will happen in actual condition. But yeah, it depends on the geology also. Say fractures or fissures, springs. If there is some fracture or fault in that area, nah, and the water can come out naturally due to those piezometric pressure also. So yeah.
This water, natural water, from where it is occurring, like if there's where water naturally flows out of the ground. Sorry, where those springs get their water from?
So through once I mean rain starts. I mean I will cover some part like how it happens, nah? But once it rains, the water will slowly infiltrate, and then so each spring it has got its own aquifer system. So there will be a aquifer zone for each spring. Nah? So it will get recharged to that aquifer zone, and then the water will slowly come out from that say.
Coming from unconfined aquifer or
Yeah. So it can be either confined aquifer or unconfined aquifer. But springs usually, say, depression type of spring, usually unconfined aquifer. But confined aquifer, let's say in case of this one, fracture spring, it can be of confined aquifer also, because through that deeper. So when we did some, I mean some of my colleagues, they did some age dating of that particular spring. Like it's more than 4,000, 5,000 years. That means it's from deeper aquifer, which is confined aquifer. No?
Kachar district, Nulapani village.
Yeah.
We have done geophysical survey.
Yes.
There, point the reciprocity variations are very low, less than 5.
Okay.
We concluded that maybe the saline spring.
Uh,
So what is the reason for that saline spring?
so especially in Kachar, or say in this northeastern where you can find saline spring, right? So it's like a trap of seawater. We know that the Himalayan ranges is like there is a plate, Indian plate, and then Tibetan plate, Tethys Sea. So mostly a trap of Tethys Sea. Na? If
We can find in all. See, it's the huge, na, sir.
yeah, huge.
That we can find in all places. Why it is in Kachar district in that particular place only. In other places we find fresh water.
Yeah, other places, but so during this sedimentary deposition, like there is some trapped seawater, and then deposition used to take place through this tectonic movement and all. So only in some particular area you can find, especially in northeastern area, you can find the trapped seawater, and then it's not like completely seawater. So when the water like infiltrate, and then it get recharged to that particular trap seawater, the water used to come off naturally through that pressure. Yeah. So we have not done any detailed study on that one, but it's like a trap seawater, and then if it rains and it gets recharged, and then the seawater it's mixed with the fresh water also, and then it comes out as a saline or brine spring. But we can find in this. I have shown one picture also. So those are mainly barrel descent formation. So in those formation you can find those saline or brine spring. Yeah, Morphe has not come. But you can ask like anything you want. No? I actually completed my presentation a bit early.
Spring water is always fresh water, sir.
Yeah. Actually, spring water in when we go to field, like during our spring studies and all, people they don't boil water also. They'll just drink from that point, and then It's I mean the water quality. Even we have done some. Did some sampling, and we found that the water quality is very good, especially in those springs. Nah? And when we compare with a deeper, especially in Nagaland, say, or say in Meghalaya also, if we go for deeper aquifer or the deeper water, nah, there is high iron concentration because the water, when they percolate, it interacts with the soil, rock, and then iron concentration is more. So usually high iron concentration is there in those deeper aquifer. But for springs, most of the springs, it's within permissible limit, and the water quality is very good. Yeah, yeah. So in my next lecture, I will talk on this hydrograph and like the spring discharge variation. So I'll just I'll cover that part also later on. This is like the first lecture, so I covered mainly the basic part, definition, classification, yeah, and the type springs in Northeast India. So my colleague, she's yet to come. So if you have any queries, you can ask. Or shall I continue my? Oh, just tea. Okay, okay, okay. Yeah, yeah. I'm telling them. Yeah, if they want any queries, yeah, we can. Yes, yes. I think you are mostly from Brahmaputra. You will be processing DPR from state government, or what is the, or state government officers? Oh, acha. Oh, acha, Meghalaya. Yeah, yeah, Meghalaya. You are from Meghalaya, no? Yeah. So while preparing DPR, like getting this basic information is also very important. No? Yeah. And okay, okay. Yeah. So yeah. Yeah, spring, especially for spring shed development and all that. Yeah. Yeah, I think we can go for tea break now. Yeah. Thank you.